This is part 2 of a presentation on the basics of probability. You can see here. This is based on the textbook Essentials of Statistics, 4th edition by Mario Triola. And this discussion will correlate with chapters 4.3 to 4.5. Notice this language in red here. Important. All probabilities are calculated by dividing a smaller number by a larger number. Put another way, probability, any probability, equals a fraction, a ratio where the smaller number goes on top and the larger number goes on the bottom, which means your answer is always going to be less than 1 if you think about it. So bear that in mind as we go through all these problems, and when you're ever in any doubt, if you have two numbers, the small number is going to go on the top and the big number is going to go on the bottom. We're going to talk about 3 basic rules of probability: the addition rule, the multiplication rule, and conditional probability. At first, we're just going to talk very briefly about each rule, what it looks like, and then after we go through that, we're going to work through a problem and apply all these different rules to that problem. The first rule we're going to talk about is the addition rule. You see there it says addition rule, and notice right after it says or. Or is the key word in a problem that tells you that the addition rule applies in a particular problem. So if you see a probability question and it's got the word or in it, you're probably going to be using the addition rule. Here is the formula for the addition rule. And we use this notation to stand for things that could actually happen. A refers to something that could happen. B refers to something that could happen. So you read this, the probability of A or B, and I'll kind of highlight that as we go through it. The probability of A or B equals the probability of A plus, you see that plus sign there, that's why it's called the addition rule, the probability of B minus the probability of A and B. So that is the complete formula for the addition rule. Notice here again in this second bullet, the word or tells you to use the addition rule. There's also what is sometimes called an intuitive approach to this rule, that is, as an alternative to the formula, which is a little more kind of user-friendly to a lot of people. And the intuitive approach to the rule is demonstrated in the example below, which we'll get to in a few minutes. The next rule is the multiplication rule, and you'll notice here we have the word and. When you see the word and in a problem, and sometimes it's kind of buried, and we'll talk about that a little bit. When you see the word and in a problem, that means we can use the multiplication rule. But we don't always have to use the multiplication rule. We'll talk about that as well. But here's the formula for the multiplication rule. The probability of A and B equals the probability of A multiplied by, that's why it's called the multiplication rule, the probability of B given A. This line here means given. And we're going to talk a little bit more about that below as well. Notice here the second bullet. The word and tells you to use the multiplication rule. There is also an intuitive approach to this rule, which is also demonstrated in the example below. Let's talk about conditional probability. The formula for conditional probability is this. The probability of B given A equals the probability of A and B divided by the probability of A. You'll see here this line, this red line right there between the B and the A, that means given. And given means we use conditional probability. Well, once again, there is an intuitive approach to this rule, which we will see in the example below. So this is the problem that we are going to answer a number of probability questions about. And this problem or example comes right from the Triola textbook. It's called Results from Experiments with Polygraph Instruments. Now, before we start answering questions, we're going to take some time to make sure we understand what this table is telling us, because for many students, they have no experience reading tables like this, and they're not sure how to make sense of them. So we're going to take some time and make sure we understand what's going on in this table. First of all, we're talking about polygraph instruments. Polygraphs are also known as lie detectors. So let's see what's happening here. We're looking at two things. One is, did the subject, that is the person taking the lie detector test, did they actually lie? So that's what really happened here. Did they actually lie? Don't confuse that with what's going on over here. These are the test results from the machine. A positive test result means that the polygraph test indicated that the subject lied. It's very important to keep this straight. A negative test result indicates that the polygraph test indicated that the subject did not lie. So these things over here are talking about what are the test results. These numbers here, these columns, are talking about what did the subject actually do? Did the subject actually lie, or did the subject actually tell the truth? So let's be sure we understand how the table works. Did the subject actually lie? This column is no. The subject did not lie. Well, for the moment, I don't want you to pay any attention to test results. That's not what we're talking about for the moment. We're just talking about, did the subject lie? Well, we've got two numbers here for subjects who did not lie, this 15 and this 32. So the total number of subjects who did not lie is the total of these two numbers. Well, that's 47, and we're going to put that number in there. So I want you to be very clear. If I ask you how many of the subjects did not lie, the answer is not 15, it's not 32, it's the total of those two things. It's 47. Well, in the same way, if I ask you, did the subject actually lie? In other words, the answer is yes, the subject lied. The answer is not 42 and it's not 9. It's the total of 42 and 9, which is 51. So that is a new row we're adding here. No, that's not supposed to look like that. This is the total row. So the total number of subjects who did not lie is 47. The total number of subjects who did lie is 51. And here, we're going to have some totals going that way as well. If I now ask you, and you really have to hear, this is a completely different question. Now I'm going to ask you about the test results on the polygraph machine. How many subjects had a positive test result? Well, that answer is not 15 and it's not 42. It's the total of those two numbers. So the total of those two numbers is 57. And then if I ask you how many of the subjects had a negative test result, the answer is not 32, the answer is not 9, it's the total of those two numbers, which is 41. And now we can see if we add these totals down, or if we add these totals across, we're going to get the same number, which is 98. There were 98 total subjects in this study of polygraph instruments. The table in your book does not have a total column or a total row. That's something you have to add. Every time you see a table like this with questions about probability, you have to make sure that you know all the totals. So that's how this table works. If you're not sure you followed all that, please play this video back again, this whole discussion. It's very important that you understand how the table works. Okay, now we're going to start answering some probability questions, all based on this table here. Let's look at the first question. If one of the 98 subjects is selected at random, find the probability that he lied. This is a very common form of question. You'll get a table like this and you'll get a question. Most of them start this way. If one of the 98 subjects is selected at random. So if you remember from part 1 of this basic probability presentation, probability equals percentage. Probability and percentage are the same thing. So we could rephrase this question to say, what is the percentage of subjects who lied? And that's our answer. The percentage of subjects who lied is the total number who lied. And remember, that's right here. That's the 51 that we put in there before. Divided by the total of all subjects. That's the 98. So the answer to this question, this probability, is 51 divided by 98, which is 0.5204. And again, remember, you can answer this probability question by converting it to a percentage question if that makes it easier for you. Let's look at the next question. If one of the 98 subjects is selected at random, in other words, this question is starting just like the last one, find the probability that he lied or had a positive test result. Well, you see this word or. That means we use the addition rule or the intuitive equivalent of the addition rule. To use the intuitive equivalent, first add up all of the groups where the people in the group either lied or had a positive test result. We don't care which one it was. If they lied, we're going to include them. If they had a positive test result, we're going to include them. So let's see how that works. We're going to look at these groups one at a time. Here's these 15. Did they either lie or have a positive test result? Well, they did not lie, so it doesn't satisfy that requirement. But if we look over here, they're in the row for positive test result. So yes, they count. That's why we have this number 15 here. We're going to include them. What about these 32 here? Did they lie or have a positive test result? Well, they did not lie. And what was their test result? Their test result was negative. So they don't count. We're not going to include them in this. So you don't see them down here. What about these 42? Did they lie or have a positive test result? Well, everything in this column is people who lied. So yes, they are included. So we've added this 42 in here. We're going to count them. What about these 9? Did they lie or have a positive test result? Well, they had a negative test result, but they did lie. So we're going to include them. So we've included this 15, we've included this 42, and we've included this 9, because each of those groups either lied or had a positive test result. So when we add them up, we get 66. So that is our numerator. We divide 66 by the total of all subjects. That's this 98 right here. That probability is 66 divided by 98, or 0.6735. So the intuitive approach is one way to do this problem, but you ought to at least be aware of the formula approach. So we're going to go through this formula approach step by step, and we see that right here in these colorful lines here. So here's the basic formula, which we talked about before. The probability of A or B equals the probability of A plus the probability of B. This is the addition rule because it had the word or, so we have a plus in here, minus the probability of A and B. Well, the first thing we want to do is be clear on what all these A's and B's stand for. And that's what this green line is for here. So we're going to say that A stands for the fact that the person actually lied. And B stands for the fact that the person tested positive on the polygraph instrument. So that's what we're interested in. So here's A, so that's the probability that they lied. Here's the probability of B. That's the probability that they tested positive. Here is the probability that they lied and tested positive, that both things happened. Okay? Well, let's see what these numbers are. We're going to come to this at the end. So let's start here. The probability of A means the probability that they lied. So again, to find that, we find the total number who lied divided by the total number of everybody. So that's 51 divided by 98, and that goes there. Now we want the probability that they tested positive. Again, here's the positive test result. We're going all the way across to the total. So the probability that anybody tested positive is 57 divided by 98. It's the percentage of those who tested positive. So there is that. But then if you'll notice what we've done, let's kind of focus on this for a second. The 51 out of 98, that's this number right here, the probability that they lied, that includes this 42 and this 9. Keep those in mind. The 42, in fact, I will highlight them. 42 and 9. They are included in this 51. Well, now let's look at the 57 and the 98. Sorry, just the 57. That 57 includes 15 right there, but it also includes the 42. So in other words, this 57 and this 51, we have double counted these 42 here, and that's not going to work. So the way the formula works is we have to be sure to subtract out or back out anything we've double counted. Well, that's the situation where you've got A and B together. Somebody lied and tested positive, and that's what happened with these 42 people. They're in the lied column and they're in the positive test column. So they have been double counted, so we subtract them out. Here's the 42, and once again, it's over the 98. And when we do all this, the 51 plus the 57 minus the 42, what we're left with is 66. So that's the answer we get using the formula, and it's the same answer we got using the intuitive approach, the 66 over 98. Okay, here's question 3. If one of the 98 subjects is selected at random, you see that pattern. So far the first 3 questions have all started the same way. Find the probability that she lied and had a positive test result. Well, you see the word and? That means we could use the multiplication rule. But in this case, it would be a lot of extra work to use the multiplication rule. So we're going to see how easy this problem is to solve without the multiplication rule. And it says here, the intuitive equivalent of the multiplication rule is much easier, so we're just going to do that. To use the intuitive equivalent, first, just find the number where lied and positive intersect. So where is that? Here's lied. This is the lied column. Here's the positive row. They intersect right there on that number 42. So that's step 1. We find where the two things intersect, and then we simply divide 42 by the total of all subjects. So that's the 98 down here. 42 divided by 98 is 0.4286. Here's our 4th question. Once again, it starts just the same as all the others. If one of the 98 subjects is selected at random, find the probability that he lied given that he had a positive test result. You see the word given? That means this is conditional probability. It is written like this. This is the notation. The probability that the subject lied given that they tested positive. The line means given. This is very important now. Whatever comes after the line, and in this case that's positive. You see the positive right there. Here's the line. Here's the word positive. Whatever comes after that is the denominator. I'm going to say that again. Whatever comes after the line is the denominator. So our denominator will be 57. Again, what comes after the line is positive. If we go to the positive row here, we go all the way to the end. The total of the positives is 57. So that's going to be the denominator of our fraction, which is our probability calculation. Then what happens is, once we have decided what goes after the line, it's like everything else disappears. I'm not going to make it disappear, but it's like all we can see now is this, because positive came after the line. The whole negative test result thing, it's like it wasn't even here. Okay? Keep that in mind. Whatever comes before the line, in this case lied, is the numerator of the fraction. And again, it says here, but we just look at the positive test result row. So whatever comes before the line, lied, is the numerator. So lied is right here, the 42, right? We're just looking at this row. We're no longer looking at the whole thing. So the number who lied, just looking at the positive test result row, is 42. So that is going to be our numerator. So when we're all done, our answer is the 42, which is the number who lied out of the positive test results over the total of the positive test results. So this 42 over this 57. There you go. That's 0.7368. And now the fifth and final question. If 2 of the 98 subjects, that should say are selected at random, find the probability that they both lied. Okay, so some different things are going on here. We're no longer selecting just 1 of the 98 subjects. Now we're selecting 2, and the question says find the probability that they both lied. Well, now this is a different kind of question. But let me point out something. Another way to say this, find the probability that they both lied, is to say find the probability that the first subject lied and the second subject lied. Well, that word "and," if you remember, tells us that we're going to be using the multiplication rule. So even though we don't see the word "and" here, we see a word that means "and." The first one lied and the second one lied. And that's what it says right here. The word "both" means the first subject and the second subject. The word "and" means we use the multiplication rule. So when you're choosing more than one out of a sample, and you're finding a probability that both of them, whatever it is, something about both of them, in that case, we will definitely use the multiplication rule. There is no intuitive version of this rule that we can use in this case. So the probability that the first subject lied is 51 out of 98. That's just, here's your lied column. It's everybody who lied. There's the 51. There's the 98. So again, that's the same as the percentage who lied. So that's the probability that the first one lied. But then we assume that the subjects are chosen without replacement. Here's this new phrase for you, without replacement. So what that means is once we chose the first person, we made them go stand outside when we went back to choose the second one. Well, that means that there's no longer 98 people that we're choosing from. There's only 97. And there's no longer 51 who lied. There's only 50 who lied. So when we're choosing the second one, that probability is 50 over 97. In other words, each of these numbers is reduced by 1 when we choose without replacement. So when we multiply these together, we get 51 over 98 times 50 over 97, and that equals 0.2683. If the problem doesn't tell you, you get a problem like this where you're choosing 2 or more. If the problem doesn't tell you whether it's with or without replacement, we assume it's without replacement. If the problem said with replacement, then that would mean after we chose the first person and found out that they had lied, we would put him back in the group and then start all over again, and the second choice would be exactly the same as the first. So in that case, it would be 51 over 98 times 51 over 98 with whatever decimal that would equal. So that is the end of this presentation.